you don't mess with this. But actually, if you want to mess with this is where you do it. This is how you do it. This is where you can say, okay, I'm just going to define my own math library, and I'm just going to use that one instead of the one that the system provides me. That is...
There'll be dragons.
Yeah.
Yeah. We're going to give you some advice here, which will allow you to fully load the gun that you're going to use to shoot yourself in the foot one day.
As people have figured that out, they have figured out ways of making this a little bit less lethal. That's why people came up with, for example, RPATH. Again, we're still in the world of dynamic linked libraries, but it's just taking away some of that power that you just gave the user. You're just overriding the search path with LD library path. I made a second C file, and I called it better add. And this again defines a function again called add, but it actually returns a different result. This one just returns a plus b. And I did also compile this in the way that I did before, but this last line here is the output is in better, which is a directory name here, / libadd.so. So this means I now have two libadd.sos, one in my current directory, one in better, and they should deliver different results because one is better than the other. What I'm going to do now, I'm going to compile this, again, my program.exe, and I'm going to tell it actually to look for PWD. It should look for this one here, the older one, the broken one. And then I'm going to add these lines back here. And this actually means, so that -w means, or -wl in this case, means everything that comes after this comma is actually not meant as an option for GCC, but it's meant as an option for the linker. So you give this option to the linker. And the option that you give is -rpath pwd. So you say, please add the RPATH PWD into the executable when you link it.
Hi. If you're enjoying this, can you click that like button? Seriously, it'll just take you like 1 second, not even that. And if you really like it, click on the subscribe button over there. We'll let you know next time we make something. Pretty easy, right? Yeah. Okay, back to the show.
Again, if I check this here, so look at program.exe and I see, well, this again, there is a needed, and here needed libadd.so, which as before, and where you would say now, okay, now you can use LD library path to choose which libadd.so you would actually use. But in this case, there's a second entry called RPath. And that actually goes to, I compiled this in my home directory. So this is home EC user, that's the default home directory. Now, if I run this, it will give me the wrong answer because it looks for this one here.
+1, right?
Yep. Yeah. And if I do LD library path to override this, well, it still tells me 4, because now this is the catch. RPath actually comes even before LD library path. So this is how people who write libraries can actually say, okay, I know my users might mess up their LD library path. There's a lot of people who like LD library path can be messed up in like your bash RC or even the system bash RC. So there's a lot of users out there who don't really know what's in their library path and don't want, so as an application developer,
we had so many support tickets from customers that were screwing themselves up with the LD library path that was longer than the Book of Moses. So we decided to take control of it before they do.
Yeah. So that's how you can put stuff into RPath. And then even if whoever your user is and screws up LD library path, or if you do it yourself, if you just know, okay, I always know this is the one version I want to use, you just put it in RPath and you're safe.
And so there's no RPath environment variable that you can set.
Good question.
This feels like just a bigger mousetrap problem in Linux.
You would think that there are people who said, yeah, I like RPath, but it's a little bit too inflexible. I want something that's a little bit more flexible. That's the great segue. Welcome to RunPath.
RunPath.
It's not the same. It's not, RPath is not short for RunPath. It's a different thing. You create a dynamic executable. Nothing weird here. That's all fine. Again, WL, RPath, and all that. But then there's this line here. Enable dtags, enable new dtags. That means, okay, it basically means linker, don't do RPath, but do RunPath. So it tells the linker to produce a program which depends on libadd.so that has a run path that goes to pwd. Again, if I check this here, program.exe depends on and all of that. So you have the needed entry, you have the run path entry, and this is really different here. So I'm just skipping back real quick to the other one. Here, this actually says rpath. And here, this says run path. It is not much different, but it is different. Now, if I execute this again, so it will, the program will actually find something because it knows where to look. It knows where to look in the run path. So it will actually look up the libadd.so and it will produce a result. But now, if I now set the LD library path to my actual better directory where I have the same library, but a different code, which produces a different result.
Okay, but what this basically means is that we've essentially restored the primacy of LD library path again.
We have, exactly. So LD library path is going to be called again, but in the first example of just having dynamic linking, the loader was lost. It did not know where to look for libadd.so if it's not in the standard path, if it's not part of the system. Here, the loader is not lost. We told the loader where to look for that library, but we still have the freedom of saying, well, I know better. Please look in this directory because I don't want the standard one. If you use LDD, and this is the shortcut, this is what you want to be using now. LDD does exactly what the loader does. So if you have manipulated your environment through LD library path or anything like that, that will be reflected in LDD. So if you do an LDD on this program.exe, it will tell you libadd. I found a libadd, and the libadd is in the home directory. But if you do that same with setting LD library path, it will tell you, I found a libadd, but it's in a different directory. So this is basically the magic list we're looking for. This is where will the loader, which ld.so, or also LDD, which basically shows you the same, actually look for stuff. The first thing it will look is rpath. If it finds something in RPath, it's done. It won't look any further. The second place it will look is whatever you've defined on your shell environment in LD library path. If stuff is not defined in LD library path, then it will look for stuff in run path. And if it still cannot find whatever library it's looking for, it will go to the standard search paths. RPath is like a hard dependency. Is like, okay, because it's looked at first, and it's like if you put something in an executable that's called RPath, that is the place it's going to look. It usually will find something there because you pointed it to the correct location, and then it will not look into your environment anymore. RunPath is like the softer version. You say, okay, this is where I believe you should look for the libraries because I know they're there, but you still give the user the freedom if they actually figure it out. Oh no, I have a more modern version of that library, and that's somewhere else. You can still manipulate that.
We're going to come back next time and we're going to talk about manipulating the binaries themselves. So you might have got some binaries from an ISV. you really want to change, say, for example, the MPI that it's using against its best wishes. And this is going to be one of those buyer beware. You may be shooting yourself in the foot. You may be causing yourself a lifetime of irritations with your ISV support department when something doesn't quite work. But if you do know better and you really need to get something working on your system that just is belligerently not working the way you want it, this is how you'll do it.
If you enjoyed this tech short, please give us a like and consider subscribing to the channel. If there's a topic you want us to focus on, reach out to us at askhbc@amazon.com. We want to make it easier for scientists and engineers to solve the world's hardest problems. We think the cloud can help by giving them access to powerful tools of any shape and size whenever they need them. And that's where you come in. Let us know what you need. We'll see you next time.